Alright, so welcome to this video on electrolysis. This one's called the electrolysis rule that everyone gets half right. So what are the electrolysis rules I'm referring to anyways? Well, there are four, and rule number one is the battery is the driving force for the reaction. Now, by remembering this sentence, we can remember a couple of other things. We can remember and recall what the battery symbol looks like. Okay, so we got the short end of the battery. This is the negative terminal, and the long end, this is the positive terminal. It's the driving force, so the force meaning that it's non-spontaneous. Also, if we can remember from the word battery, that battery means electricity, so we are inputting electrical energy and we are outputting chemical energy. That's our energy conversion. Okay, so that's rule number one. Now, rule number two is an oil cat rig. And what does this stand for? Well, this stands for anode. An stands for anode, is the site of oxidation, and oxidation is loss of electrons. Right? Just keep in mind as well, anode is the site of oxidation. Does not necessarily mean that the anode is the thing that is undergoing oxidation. Okay, now cat rig. So cat stands for cathode. Cathode is the site of reduction, and reduction is gain of electrons. Okay, now from here we can do the rule for electron flow. So electrons will always flow from anode to cathode. This happens all the time. Okay, so we'll indicate that by drawing this little arrow with the electrons on top. All right. In addition to electron flow, there is also a rule for ion flow, and I'll write that together in rule number two. Now that rule is cations, which are positively charged ions, they will flow to the cathode. So cat flows to cat. And anions, which are negatively charged ions, they will flow to the anode. An flows to an. Now this in fact is not just a electrolysis rule, this is a redox rule. So this will also apply for galvanic cells. Now, rule number three, and I should stress that it's important to think about these rules in this order. What is rule number three? It's that we have to ask ourselves, the battery is forcing something to happen. All right, it's forcing oxidation and reduction, but we want to think about what happens at the anode first. So we ask ourselves the question, what is the battery forcing to oxidize at the anode? Okay, now in order to figure that out, we need to know the strongest reductant will oxidize, and the strongest reductant will react with the strongest oxidant. And so the rule number four will be what is reduced at the cathode. Okay, and this will be the strongest oxidant will reduce. Okay, now out of all of these rules, the one that we kind of get half right is actually this rule 3 and rule 4, because we all know that the strongest oxidant and strongest reductant will react. But what we need to keep in mind is that they have to be available at those electrodes. Okay, so the strongest reductant will oxidize, but it's not just any reductant, it's the one that is available at the anode. Okay, so the strongest reductant available at the anode will oxidize, and the strongest oxidant available at the cathode will reduce. Okay, so we want to use these rules now, and we want to apply them to some scenarios. And the first scenario here is the electrolysis of sodium chloride. Now this is molten sodium chloride. And so we've got our electrochemical series ready to go to help us answer this question. The strategy is to find all of these chemicals on our electrochemical series and apply the rules. Okay, so we can see the battery. You can see the negative terminal of the battery here. This is connected to the negative electrode, and the negative electrode is the cathode in electrolysis. The positive terminal of the battery is the anode. The anode is graphite, and the cathode is copper. We've got molten sodium chloride, so there's no water present. Simply, we just have sodium ions and we have chloride ions. And if we find these on the electrochemical series, we can find chloride over here, and we can find copper over here, and we can find sodium down here. Okay, now we've got to go and apply these rules. The battery is a driving force. We kind of already did that rule. We figured out the terminals of the battery and which one's the cathode, which one's the anode. Now we know that at the cathode, second rule over here, cathode is going to be reduction. So reduction is going to happen here, and oxidation is going to happen at the anode, which means that the electron flow is going from right to left, and ions are going to flow in a certain direction. The cation, the sodium, this is going to flow to the cathode. Cations flow to the cathode, and the anion is going to flow to the anode. All right, now what is going to react? Well, we're going to figure out what is the battery forcing to oxidize, and we have to check if it's available at the anode. Okay, and it's the strongest reductant that will oxidize at the anode. Well, according to our electrochemical series, the strongest oxidant is the one furthest down on the right-hand side of these arrows. All right. So on the right-hand side, if you want a good way to remember it, right starts with R, and reductant also starts with R. So on the right-hand side, we've got our reductants, and the strongest reductant is the one at the bottom. Strongest reductant. The strongest reductant will oxidize. So copper technically is our strongest reductant. It is stronger than chloride. Will it oxidize? We have to check if it's available at the anode. And it's not, okay, because copper is actually the cathode, and it's fixed in place. It's not available at the anode. So this reaction will not take place. What is the next available reductant? That's the chloride. Okay, so this chloride will become chlorine gas. So we'll start to see some bubbling over here at the anode of chlorine gas, and it is escaping. Okay, let's just write the equation here at the anode. It would be 2Cl minus becomes chlorine gas and 2 electrons, and those electrons are going to flow around the circuit to the cathode. And at the cathode, we have got the strongest oxidant now, and there's only one oxidant available at the cathode. That's our sodium ions. Okay, this is the strongest oxidant. Remember, oxidants will undergo reduction. Now, we did just produce something stronger. As you go up the series, you get stronger, actually. But this chlorine gas, it's bubbled away, and it's not going to the cathode. So it cannot be reduced at the cathode. That means that the only available oxidant is the sodium ion. And so that will undergo reduction. Sodium plus electrons gives you sodium. Okay, and so that is our reduction reaction. Now let's apply the rules to the second scenario here. And here we've got the same setup. The only difference is we've replaced the anode, which was originally graphite. We've now made it copper. Okay, so this is still the anode, This is the cathode. All right, so electrons are still going to flow around this direction. All right. Now, we've still got the same chemicals present, but the one thing that changes now is that copper is now available at the anode. So instead of making chlorine gas, we'll actually make copper ions. So that equation, right, will not happen. We will actually do this equation. Okay, so copper 2 plus is being produced. And remember, when we apply the rules, okay, we always figure out what's happening at the anode first, and then we can proceed to figure out what's happening at the cathode. Now, we've just produced copper 2 plus. Inside the electrolyte, we still have our sodium ions, our chloride ions, and our copper 2 plus ions now, because they have formed as a result of the anode oxidizing. Now, when you have a look at the strongest oxidant, now the copper 2 plus is available, and it is a cation. It is in the electrolyte. It can also flow to the cathode. Sodium can also flow to the cathode, right? But sodium is no longer the strongest oxidant available. The strongest oxidant available is now the copper 2 plus. So at the anode, you'll have oxidation of copper occurring. Copper solid will oxidize into copper 2 plus and 2 electrons. And at the cathode, you'll get copper reducing back down into copper solid. All right. Now, what's happening to the chloride? Sorry, the chloride is still an anion. It's still flowing to the anode, but it's not reacting at the anode because copper 2 plus, because copper solid is a stronger reductant than chloride. Okay. Now, let's look at a final example. This one here is the electrolysis of sodium chloride solution, and this is a 1 molar sodium chloride solution. We have 2 electrodes and they are both made up of graphite. We've got our anode on the right and our cathode on the left, and so the electrons are going to flow in the same direction as before. And we still have sodium ions present in solution. We still have chloride present in solution, but now we've got a solution. So we've got H2O present. Okay. There's water present, which can be a reactant. So now we have to look at our electrochemical series again and determine what is going to be oxidized and what's going to be reduced. Okay. So we'll highlight everything that's in our scenario. We've got water. We've got water down here as well. And we have sodium ions and we've got chloride ions. Now there are a lot of other water molecules sitting up here. These ones do not matter. The green ones don't matter. But this one here potentially can matter. But because H2O, which is sitting here, is a stronger reductant than the H2O up here, this reaction ends up playing out more than this top reaction. All right, anyways. Now, we have to figure out what's available at each of these electrodes. So what's available at the anode? Well, chloride is available at the anode, but so is water. And water is stronger because it's lower down on the right-hand side. So water will end up oxidizing. So we'll get 2H2O will become O2 gas plus 4H plus 4 electrons. Those electrons are going to be sent around the circuit to the cathode. Now, what's available at the cathode? Well, we've got this sodium ion and we've got the water molecule that's available at the cathode. These are oxidants. Now, the strongest oxidant is water. So water will end up reducing. 2H2O plus 2 electrons gives you H2 gas and 2OH minus. Okay, so those are our two equations. So that's the rules of electrolysis, and the order in which to think about these rules I think is very important. Figure out what is oxidized at the anode first, because that might give you possible reactants that can react at the cathode. And that pretty much wraps up the video, the electrolysis rule everyone gets half right. Hopefully you won't be getting this rule half right anymore. And if this video helped, hit the like and subscribe so these keep showing up. You can find me on Instagram for quick VCE chemistry breakdowns, and everything including upcoming courses and programs is over at Beyond the Bond. Stay tuned, there's a lot coming. See you in the next one.